guessing. No, that's okay. You never learn right
We
now.
never used these when I was in school.
Well then we didn't either. I know. But let's learn it right now. Let's learn it right now. When I make a statement like that, Christina, the only reason I'm making that statement is because technically speaking, 105 has this mandatory prerequisite of 95. And when I taught 95 eons ago, it was pretty much, we were always in these things.
Always.
Like constantly in the, anybody else has 95 experience like that? Yeah, you're just always in those things. They're augmenting everything we do manually with the technology. So anyway, when I went like this, your TI can do that. I do recommend, in order to learn how to do this, go back to your TIs, and to make life a little bit easier for you at this process, I would turn your scatter plot off. And the easiest way to do that is to press the Y equals button, and then you see how that plot 1 is highlighted right there? Just put your blinker on top of it and press enter, and that turns it off. And now, when you press the graph button, you simply get the line without the scatter plot. See, the scatter plot's great, but honestly, the scatter plot is, I call it a first pass. Look at the data, and then you decide what shape it is. And we decided early on, it looks like a line. It's like a diagonal line. Once you've decided that, all the calculations that follow are all you have to worry about. The scatter plot just got you to that point. So, more on that momentarily, because that is part of the fun of statistics, is trying to figure out which model looks the best. I remember doing some work for the police department at Bend about 10 years ago, and they were trying to figure out what the population of Bend was going to do, which, trust me, is not the easiest thing to figure out. They were trying to figure out how declining budgets were going to be met with this population change. And looking at the data of Bend's population growth over the past 20 years is fascinating. It's totally crazy. It goes through these microcycles. It's almost like the weather here. Maybe that is the weather. Maybe it is. So anyway, that's the line. So remember my finger that I drew across, that Y equals 40? I went up to Y and drew a horizontal line at Y equals 40. We can do that too. Ready? Press your Y equals button. Leave that equation there because we want to intersect that one, as Ashley pointed out. But go down to Y2. What are you going to put in? Y2 equals 40. Yes. 40. And then press graph. And you'll see a magical line come across, like my finger did. Hits it right there. At some point, those lines are going to intersect. That's the definition of intersecting lines. Now, how do we find out where they intersected? That's okay. That's why we're doing this. Mary, help me out. Yeah, that's one way of doing it. Yes, that's one way of doing it. There's a more direct way, though. I love that. You can totally trace. Hey, you can totally trace. And as far as precision goes, Mary, that's perfect. So you can hit that trace button, and then you can scoot your spider until you get close. That's pretty close, yeah? It's blinking pretty close. It looks like it's right about at 6.7. But tell me again. Sumi, go.
You can use another Python calculator, which is calculate.
Yes, ma'am.
And it will actually.
Yeah, I need to be excellent.
Yes, that's what.
So, Sumi's got a more direct solution. Mary, I got no problem with the scooching. No problem with scooching whatsoever. You can totally scooch and get close. 6.71 is damn close to 6.57. But if you tire of that, watch this. This is pretty slick. And this is one of those Math 95 skills. Press the second function button. Now press the trace button again. The trace button that we just pushed, you're now using what's called the calculate menu, which Sumi mentioned. This is above the trace button, and there's all kinds of goodies in here. There's everything from basic algebra to calculus in this menu. It's freaking rad. The one we want, as you may have guessed, is called intersect. Number 5. Go ahead and press 5. Press 5. Now the TI, as wondrous as it is a dumb machine. Because you and I can see exactly where the intersection happens. We can look up there and go, oh look, it's like an X. And the X is where it crosses, that's the intersection, right? TI has no eyes. The TI has no eyes at all.
None?
None. 0.
Is it the AX?
The AX. The AX. No, the TI itself. No, your machine is a dumb machine. It has to have its hand held. So you see what it's asking you? It says, hey, you, should I use 1.05x plus 33.1 as the first curve that's being intersected. And you want to tell it, yeah, that's the diagonal, right? How do you tell your TI yes? You press your enter button one time. And then it goes, oh, thank you. What should I use for the other one that's actually hitting it? Should I use y2 equals 40? Enter again. And then it goes, oh, could you give me a guess? And I say no, and I press enter a third time. And I'll come back to why I don't care about that momentarily. You press enter, boom! And there it is. 6.57, which is what we got by solving it that year. Cool? Brittany?
Okay, I did a totally different.
Tell me how you did it, my friend. Hang on, hold that thought for 30 seconds. Is that okay? It's recorded on video if you need it at home, okay? It's probably going to be about the 5th video in today, but it's recorded there if you need it. The steps are all there. If anybody needs more, I've got a booklet I can send you on how to run the intersect command. I've got one from Math 95 I used back in the day. I'd be more than happy to email it to you in PDF form. Learn that. Go, Brittany.
Okay, so this one works if you wanted to get an exact number in the calculator, like how But I just, from what I did, I knew it was between 1996 and 1997.
Good for you.
So I just went to the table set and then turned the, should you want to wait?
No, keep talking. I'm starting the video again.